Hello, good morning. Welcome to MongoDB.local Toronto. Thanks for making it out for the early bird session. Very excited to introduce my colleague, Will Chow. Will is an advisory solutions architect at MongoDB, focused on helping enterprises design and build reliable, scalable systems using MongoDB. Welcome, Will.
Hello. Hi, folks. Welcome to and good morning to the first session, or one of the first sessions for MongoDB.local Toronto. It's good to see you in person for a very long time. And just before we get started, just a couple of questions. And just a show of hands. So who here has used MongoDB Atlas before? Okay. And who here has used MongoDB, whether Enterprise Advanced or Community, but haven't used Atlas? Okay. So for today's session, what we'll do is we'll go over a high-level overview of MongoDB Atlas. And also, it'll be a little interactive, so hopefully you have your laptops, but if you don't worry, no pressure, it's a safe space. We'll be setting up an account if you don't already have one, then showing you how to spin up a free cluster, and then load some sample data in, set up database and network connectivity, and then show you how you can connect to it. And by the end of the session, you'll have a fully managed, fully deployed, distributed MongoDB Atlas database for you to learn MongoDB if you want to play around and learn the MongoDB Atlas platform, and also to build tomorrow's next best application. All right? So by 2023, just around the corner, over 500 million digital apps and services will be deployed and developed using cloud-native approaches. And nearly all of those cloud-native applications will require a database, right? In the cloud, when you're deploying a database and when you're deciding what database to use, well, you have to think about what are the provisioning hardware or the VMs that are in the cloud. How many do I need? Is it distributed, right? Making sure that the operating system is the right one, the software is up to date, and also deploying the binaries for the database and making sure ongoing that you upgrade it and maintain it as patches are being released. And also for your application, like how do you connect to this database, right? Is it through peering, right? Is it a distributed environment? Are there many different VMs and resources that you have to connect to? Is it going to be accessed through private link, right, or private endpoints? So these are the things you have to consider with a distributed database if you decide to deploy a database in the cloud. And also, importantly, security, right? Because you want to make sure that the data that you're placing in the cloud is authenticated to the users that are only allowed to use the database. You have authorization in place so that only those who can access it or are authenticated, can do the things that they're supposed to do. And also ensuring that if you need auditing for compliance, that's in place. And also encrypting the data, whether it's at rest or in transit, whether it's from your application to the database, or even if the database is distributed, is that data encrypted as well? Or if you need field level encryption. You also have to ensure that, did you set the database up so that it's resilient in case a region failure, or even a cloud provider failure, or just a VM failure, and making sure that your applications can scale. So if it's wildly successful, or if you have seasonal workloads, it can scale up, scale down, or scale out, right, for organic growth. And if you're coming from a relational background and you're deciding, oh, if I'm using a relational database, well, I have to plan on building or rebuilding my DDL, right? Making sure I have the structures in place. And also ongoing, day 2, if I need to add features or improve my application, well, making changes to the DDL, right? If I decide to use, for example, a relational database. And if I have a new application or an existing application, I have to validate that the features work as they're supposed to. And down the road, well, if I need to make changes, I'll also need to make changes to the database. If I'm using a relational database, I have to change the DDL. And that adds a lot more time, right? Because it's not just about changing the database, I have to change my code. So these are the choices that need to be made when you're deciding to move cloud-native applications to the cloud. And this adds a lot of friction, right? All these things, when what you're really trying to do is be more productive. And what we're doing with MongoDB and MongoDB Atlas is to eliminate that friction so that you get a better experience and you're more productive in the cloud. And if you've used MongoDB before, well, a lot of things that I mentioned before, especially building and managing DDL, right? That's something especially for modern applications and using the document model, you don't have to do. If you're migrating or modernizing in the cloud, well, there's tools available for you to make that transition to a more optimized and future-proof model where you can make changes and adapt and improve your application iteratively and more efficiently. And with MongoDB Atlas, what we're providing is a multi-cloud database as a service. And it runs in AWS, Microsoft Azure, and the Google Cloud Platform. We're also, as MongoDB the database, if you use it, providing a unified query language for you to run optimize operational transactional workloads. You can find your data with database queries, index that data so that you can do fast lookups, right? And handle thousands or hundreds of thousands of users with low latency, and also provide the ability to do different types of workloads using our, in the same query language, the aggregation framework and pipeline. So you can look at your data in different ways and put the data through different stages, transform it, provide even windowed analytics on your queries. And also, it has the ability to auto-scale. So if you have seasonal workloads, it can scale up, scale down. We have options to scale out, too, for organic growth. And if you need to visualize your data for reporting, if you need to create dashboards and charts, well, we have built into MongoDB Atlas, Atlas charts. As well as part of operationalizing your database, oftentimes you need to do backups, right? So it provides the ability to do not just backups and snapshots, but continuously backing up your data. And also on the Atlas platform, we have the ability to do online archive so that that data, the historical data that you still need is still accessible and you can still query it along with your current data that you need. And also extending the capabilities to not just transactional operational workloads, but putting that data into an optimized columnar format so that you can query it in the data lake in cloud storage. And also, what I'll touch upon is the ability to not just run database queries, but full text search queries so that you can do things such as autocomplete, fuzzy matching, and just search your data more completely rather than just doing database queries, which you can also do. And also providing the ability to react to changes in your data with triggers so that you can have event-driven architectures. And if you're, when you're querying MongoDB using our drivers, our idiomatic drivers, Java, C#, Node, you also have the option to create a data API so that you can access the data easily through a RESTful interface, through HTTPS endpoints. So that's also available to you. And we have monitoring and alerting in place already built in so that you don't have to implement that yourself. And on top of that, we have performance advisors to let you know if you have slow running queries or index suggestions or schema changes and recommendations which you can make. And MongoDB Atlas is available globally on, as I mentioned, the 3 major hyperscalers across over 95 regions, and all the regions here in Canada. And the goal of that is to eliminate that friction, right? And really, truly, for developers, application teams, organizations, large and small, to build better apps much more efficiently and faster, right? So again, I'm Will Chow. I've been a software developer for many years. I do enjoy running when I can, and I do some renovations around my house, but my true passion and what I love best is working at MongoDB, and I'm a solution architect, and I'm based here in Toronto, and I've been with MongoDB for 4 years, and what we'll do today, if you'll indulge me, is we'll create a MongoDB Atlas account, right? And I'll walk you through that. So there's really 2 steps. No pressure again, but if you can go to step 1, right? https://account.mongodb.com/account login. And if you already have an account, that's great. If you don't, feel free to use any email address, but that email address you'll have to have accessible so that you can get an email to verify that that's truly your address, so that your account is activated. So I'll walk through that with you. So again, if you missed that, it's account.mongodb.com/account/login. Okay? You come to a page which looks like this, and if you already, as I mentioned, if you already have an account, then simply log in. If you don't, then you can just sign up. Yeah, hopefully it's big enough. So it'll just be an email address. Just your first name and last name. A password. Oops. Sorry. Okay, and then accept the terms, sign up. And then now to your inbox, and since this is not my own laptop, okay, you'll get a notification. If you don't see it, check your spam folder. And then just verify that email address. Okay, it's verified for myself. And since I'm not using this computer, let me just refresh this. Or just go back. Let me just, oops, okay. Oh, okay, so it logged in for me. And it created for me an organization and a project, a default project, for me to create MongoDB deployments. If you were using your same laptop, you probably see a screen such as this, which is just a couple questions to help tailor the experience for you. So for myself, I'll just put learning MongoDB as what my goal is today. And for what type of application I'm building, you can put, like, for example, application modernization and just the preferred language. It doesn't matter which language. We support, we have a dozen drivers for you to use any modern programming language. So for myself, I just put JavaScript. Okay, let me just go back. And what we'll do, okay, is go into that project. Okay, and what you'll see is that you have the option to build a database, all right? And you do have the options to choose which cloud provider you want this free cluster in, whether it's in Microsoft Azure, right? There's a region in Toronto, Canada Central, which you can use. There's for Google as well, or AWS, okay? So I'm just going to quickly choose AWS. You can pick whichever region you prefer, and simply name the cluster, right? So I'll just call it local Toronto. And then what we'll do very quickly is just set up database and network access. So the first thing you do is just specify your username. So I'll just pick one. Okay, create that user. And this is using SCRAM authentication, salted challenge answer response. So you can have also X509 certificates. Additionally, if you want a more advanced configuration, you can also set it up for LDAP authentication and authorization. But for now, we'll just create a user, a database user, and also how you would connect to it. So in more advanced environments, you can set up peering. You can set up, if you're on Google, use private Service Connect to create private endpoints, or AWS or Azure Private Link to create those. But for this, I'll just use my local environment. I'll add my current IP address, which is the address I'm connected to here. And by default, there's no access to this cluster. So you have to explicitly add the IPs if you're connecting, for example, publicly to it, but no other IPs or CIDR blocks will be able to connect to it. Okay, so if you leave this blank and only decide, okay, I only want to connect through a private connection, through whether it's VPC or VNet peering or just through private endpoints, you don't have to configure this, and it'll be blocked off from public access. But for this purpose, if I'm at home, if I'm just playing around, there's no sensitive data, then I can say, okay, I'll just use my own IP address, right, and add it here, and just finish and close. And then go to my database. Okay. And this is provisioned for me already. Okay. And what I'll quickly do here is go to the three dots. Okay. And you have the option of loading your own data, but we have sample data for you to play around with, right? And the sample data consists of a number of databases, and in those databases, a number of collections. For you to explore and learn MongoDB. Okay, so I'll just load some sample data. Okay, this will just take a few minutes because the cluster is provisioning. But in the meantime, what I'll show you is once that data is loaded, this cluster is up. Okay, what you can do is how to connect to this. So you just click the connect button, and it will give you a number of options of how you can connect to your MongoDB Atlas cluster, whether it's through the MongoDB shell, right? And then it'll give you options if I'm using my a Mac here to install the Mongo shell and the connection string, right, which is an SRV record. Or if I'm connecting from my application and I'm using one of the dozen drivers that MongoDB fully supports, whether it's Node.js, PHP, Python, whether it's Java, C#, then I'm provided with how I can connect to it, right? Same, connection string. Or if I'm using the MongoDB graphical user interface, MongoDB Compass, then I can also connect through there as well. I can download it, or if I already have it installed, then I can just simply get this connection string and connect to it. Or if, like many developers, you use Visual Studio Code, you can also use that as well. And the instructions to install it are listed here, step by step, so you can easily connect from VS Code. The other option is, if you're not using these methods, you can also enable the data API, as I mentioned before. So if you want to easily create RESTful endpoints to access your data, and you're not using one of our drivers programmatically, then you can use it and access the data through our data API. Okay? And just to go back, while this is loading, let me just show you. So this cluster is deployed as a replica set. So it is distributed, right? There's 3 nodes, there's primary, 2 secondaries. You have a real-time dashboard for you to gain insight and to see what's going on. You can also look at your collections here when it's loaded. I'll touch briefly upon how you can easily create search indexes on your data without moving your data around. We have a profiler to analyze and diagnose slow queries. We have a performance advisor so that if you're running a workload and perhaps there's some indexes that you can create, because you can create any number of secondary indexes in MongoDB to optimize and speed up your queries. And as I mentioned before, we have an online archive to automatically archive your data on top of backing up your data. Okay? And just to go back while this is loading, so it doesn't require a credit card. You can spin it up. It's free forever. It's perfect to play around or to start building your next application. And this is built upon MongoDB's and allows you to use and leverage the document model, which is a modern standard for modern applications as you modernize, and is a superset in that you can, of data models, in that you can represent, for example, key value pairs. You can have, for example, graphs and graph lookups. You can also have relationships. So whether you have a rich document, you want to embed the relationships, or you have separate collections and you want to do lookups on each, you can do that as well. And also geospatial, GeoJSON data for you to look up different coordinates, polygons. We have the capabilities of incorporating and using and storing time series data as well. And we have a session on that today. And also for developers to represent just your objects and store them naturally in the database, because we do use a document model, which is a rich JSON format. And this is all provided with a unified interface so you can query it with one language. So whether it's transactional operational workloads, you have the requirements where there's hundreds of thousands of users, you need sub-second queries, we have that capability built in. And also what I'll touch upon is the ability to do search queries, right? Which is for some of you maybe new. And also to do analytical workloads, to look at your data not just through finds but also to do aggregations, windowed queries, look at your data in different ways and massage that. And this is to build distributed applications, whether it's a mobile application, whether you have a number of microservices or they're serverless. You have this database which is built on the foundation of security, right? You have security in place, and also being able to have a resilient platform. So if you're building a mission-critical system, you have something that can withstand whether it's a VM failure, a region failure, or even a cloud failure, because MongoDB Atlas is a global database, and it's multi-cloud. Oops. So as I mentioned, we do have, as part of MongoDB Atlas, Atlas Search. And what does that mean? So in the past, we'd have many users use MongoDB as an operational transactional database. And if they wanted to power a search bar, well, what they would do is they would replicate that data to, for example, an Elasticsearch or Apache Solr, right? But a few years ago, what we introduced, and this was actually before the pandemic, the ability to have an integrated and fully managed search engine with the same data without having to move it or ETL it to another platform such as an Elasticsearch. And this has been available in Atlas since we released version 4.2. So as long as you have a cluster in Atlas that is version 4.2 or higher, you can enable search indexes directly on the data that you already have in MongoDB. It's very easy to use. You simply create an index within the interface, and then to query it, you use the same unified query language. Just using the aggregation framework, there's a $search stage for you to do different queries, whether it's autocomplete, fuzzy matching, right? You can do scoring of your data for relevance. So what this provides is we're not reinventing the wheel. We're using the same search library as the open source Elasticsearch, OpenSearch, Apache Solr, which is Apache Lucene. It's been around for decades, right? It's been battle tested. It has a lot of advanced features. And what we're trying to do is simplify the architecture so you don't have to move data around and have it in different places. This is using the data that you already have in MongoDB Atlas. And also, as I mentioned before, if you want to visualize the data, you can do that naturally very, very quickly with MongoDB charts, because MongoDB charts is built for the document model, the richness of it, whether it's you have sub-documents or arrays. There's no data movement to or ETL to other platforms for reporting, and it's integrated. So you have a single platform that you can easily use within the same interface, and you can share and collaborate these dashboards and charts with other users, whether embedding them in your application or through APIs. And it's very powerful because you can create visually engaging data experiences so you can drive more insights. And just very quickly, because we have a few minutes here, you also have the ability to do data federation in that you can run federated queries between different clusters, different databases, and even between cloud storage, such as S3, so that you can aggregate the data and look at it in a different way. So this is all available within MongoDB Atlas. As well, I mentioned multi-cloud, and what does that mean? It means that not only can you deploy clusters in, say, Google, AWS, or Azure, but you can deploy a single cluster across multiple clouds, like one cluster with your replica set spread across different clouds. And this allows you to have continuous availability with cross-cloud redundancy. So for example, if you spread out your cluster through Azure, GCP, and AWS, if one of the cloud providers goes down, you still have the resiliency in a single replica set. It also allows you to migrate very easily. So if you have your cluster today on Microsoft Azure, but later on you decide, oh, your company's moving towards Google Cloud, you just change the configuration, and those, without any downtime, that data can easily be migrated to another cloud provider. So this gives you tremendous flexibility. And also, if you just want to simply take advantage of some services, say you want to, your cluster is in AWS, but you want to leverage some, say, machine learning and AI services in Google Cloud, well, you can also have nodes there as well in the same cluster with the same data. Okay? So this allows you to reach more users, more regions globally. Okay? And especially in Canada, we have in Toronto 2 regions, right? One for Google, one for Azure, and then Azure also has a region available in Quebec City and Montreal. And just very quickly, I just want to show you how you can easily do that. Oops. If you go to your database and you create a new cluster, right? What you can do is very simply create this multi-cloud, multi-region. Okay, so say I picked AWS, and by default it's deployed with 3 nodes. And say I wanted to keep it, say, in Canada, so Montreal, okay? Those 3 nodes would be placed in Montreal. But I can easily add another region, right? And say, okay, well, AWS has 1 region, and I want to leverage another region, and the data has to be in Canada. Well, I can say, put the other node in GCP, right? And I can pick Toronto as another region. So I can distribute 3, 2, but if you're aware of the MongoDB replica set, as a best practice, it's best to have odd numbers, right? 3, 5, 7. So I can also say, okay, I want to leverage another cloud provider in another city. So Azure has Quebec City, Canada East, as another region. And when I can deploy this cluster, with 2, 2, and it has to add up to an odd number. So this is a 5-node replica set distributed across cloud, cross-provider, and allows it to be fully resilient and automated, for example, if one of the regions were to fail. Okay. All right. And so just to wrap up very quickly, so MongoDB Atlas allows you to very quickly and easily use and deploy MongoDB, but also it provides a lot of security and compliance in that we undergo independent verification for platform security, privacy, and compliance controls. In fact, over 37,600 customers as of last quarter use MongoDB Atlas. Big banks, credit card processing companies, telcos, retailers, they all entrust MongoDB Atlas for their most sensitive user and application data. Okay? And the purpose is to help you eliminate that friction and focus on building better apps faster. Okay? I think I'm out of time, but thank you for coming today. And if you have any questions, I'll be around, so you can feel free to ask me. And please fill out the survey. Thank you.